Okay, so for finding this derivative, we have to use the limit definition of a derivative, which you're going to have on the final. The limit is h approaches 0 of f of x plus h minus f of x over h. So what you do is you take the whole function, right, and you plug in x plus h for this first part, and then you just rewrite the function for minus f of x, and that's going to be all over h. So we have the limit as h approaches 0 of 4 root x plus h plus 5. So this part is this part, f of x plus h, minus, alright, so in parentheses we're just going to put our original function again, 4 root x plus 5. Okay, so then this part is this minus f of x right here, and then we just put it all over h. Okay, this isn't important for the test, but you need to, if you're going to understand this problem and feel confident about it, you need to know what you're doing is you're trying to find the slope of a tangent line through any point on this function by taking the average rate of change between 2 points, the point being x plus h comma f of x plus h, and x comma f of x, and then you take the limit as h approaches 0 so that they become the same point. But we can't plug in 0 for h because that would give us 0 over 0, which is a whole, so we have to cancel out that h on the bottom. So to do this, what we have to do is we have to multiply by the conjugate. So to keep this straight, what you should do, and I'm actually going to rewrite this lower so we can really be careful about this. So I'll pause for a second. Okay, so what we need to do is we have to multiply by the conjugate to simplify this and get the square root out of there. So this is the thing where people always get confused about how to switch the sign and whatnot. So what we need to do is we call this A. It does not look like an A, does it? A. And then we can call this B. And when you do the conjugate, what you're doing is you're going to do A minus B. So what we have is A minus B, so we're going to multiply by the conjugate, which is A plus B, over A plus B, because we can't just, we're multiplying by 1, so we're multiplying by A plus B over A plus B, because that's not going to actually change the function. So what we have to do then is we have to rewrite A. So we're going to write 4 root x plus h plus 5. Okay, and then we're going to take this minus sign and change it to a positive sign, so a plus sign. And then now we have to rewrite b, which is 4 root x plus 5. Let me write that a little better. X plus 5. Okay, and then we have to do that on bottom as well. So we have 4 root x plus h plus 5. All right, and then we're adding 4 root x plus 5. Okay, so the reason we're doing this, and again, like, this isn't, you don't have to explain this, but if you're gonna know what you're doing on the final, you should understand this, is because when we do a minus b times a plus b, that gives us, if we FOIL it, right, first, outside, inside, last, we get a squared. That's first. Okay. Minus ab plus ab plus b squared. Okay, so you can try to FOIL that yourself and see what happens, but this minus ab and plus ab cancel, so then we're just left with a squared plus b squared. Alright, so what may be good for you to do if you mess this up a lot, like some people just do this in one quick step, but what you can do is you can say, well, what is a squared? Okay, well, a is up here, right? So let's write it. A squared, that's equal to 4 root x plus h plus 5 squared. Alright, well then we have to square both pieces. We have to square this piece and this piece, which gives us 16 times x plus h plus 5. Alright, so when we do this multiplication up here, what we're going to get is we're going to get a squared, which is this, and then we're going to get minus b squared. Why did I say plus b squared? That is a good question, a valid question. So let's go back up here, and then let's see why this is minus b squared. It's because when we multiplied, we have a minus b and a plus b. When we multiply those together, we get a negative b squared, not a positive b squared, sorry. So we have our a squared now, and now we need to find our b squared, which is going to be a similar thing. It's just going to be 16, right? 16 times x plus 5. So let's write this fully out now. And then on bottom, right, this is where we can save some time. We have h times all of this. We have to keep writing all of this every time until we get to the end. So what we can do is we can actually just call this whole thing k, so we don't have to keep writing it. Right? So now, knowing that, let's see where we're at. So we multiply by the conjugate, and we got 16 times x plus h plus 5, okay, minus 16 times x plus 5, and then that's all over h, and then we're just going to call this k, right? And we're still taking limit as h approaches 0. Okay, so now let's simplify. 16 times x, 16 times h, 16 times 5, negative 16 times x and negative 16 times 5 gives us 16x plus 16h plus 80. Alright, let's move this over so I don't run out of space. So we get 16x minus 16x minus 80, and then that's still all over h times k. We're still taking the limit as h approaches 0. So then this is good because we can cancel 16x and negative 16x, and we can cancel 80 and negative 80. All that's left is 16 times h over h times k. Since this is all multiplication, we can actually just cancel that h. We're just left with 16 over k. So now we have to write k again, unfortunately. So we have limit as h approaches 0 of 16 over, we have 4 root x plus h plus 5 plus 4 root x plus 5. And now since we've canceled our whole, our h, we can plug in 0 for h. So now we can finally plug that in. And what that's going to do is it's going to, one sec, gotta erase this. So we're going to go over here to the left. What it's going to do is it's going to give us 16 over 4 root x plus 5 plus 4 root x plus 5. And then this is good because these are it's 4 times something and 4 times that same thing. We can combine these. We can add them to get 8. So we get 16 over 8 root x plus 5. And then if we want to really finish this and simplify it, we can finish by saying that 16 divided by 8 is 2, so we get that the derivative is equal to 2 root x plus 5. And then there is our final derivative. It asks you to plug in -1 to the derivative, so if we really want to finish this up, then we're going to have to do that. So that's f prime x, so if we plug in f prime -1, we get 2 over root -1 plus 5. Alright, well you know -1 plus 5 is 4, and the square root of 4 is 2, so then our final answer is that this simplifies as just being 1. So f prime -1 is 1. The slope of the tangent line at -1 of our original function is going to be 1. Cool. So if you really struggle with this, I would go back and do this problem again. Maybe watch the video one more time, and then do a couple of those practice problems again from the study guide. Okay, I remember that we need to verify this using the power rule. I forgot that told you to do that. So what you have to do is you have to take this square root and you have to rewrite it using an exponent, and you should know by now that the square root of x plus 5 can be rewritten as x plus 5 to the 1/2. And then you have to remember the power rule. Use your derivatives project if you don't, but we take this 1/2 and we're going to multiply it by the 4. So we get 4 times 1/2 times root x plus 5. And then we are going to have 1/2 minus 1. All right, that's the power rule. We multiply by the exponent and then drop it by 1, which gives us, okay, 4 times 1/2 is 2. And then we have x plus 5 to the negative 1/2. And then when you have a negative exponent, you know that you can take the piece that the exponent is attached to and drop it down to a denominator. So then that's going to be equal to 2 over x plus 5 to the 1/2, which can then be rewritten as 2 over square root x plus 5, which is what we got by using the limit definition. So that's a good way to check your answer.